One very important measure of variation when we talk about analyzing data is called the standard deviation. And this one is a little bit different than the range. We already talked about the range. Remember that the range was just the highest data value minus the lowest data value, but it doesn't really tell us a whole lot because it only involves two values. We want to know what's going on in the middle. We want to know what's going on everywhere in a data set, not just from what we get from the lowest and the highest. So the standard deviation is a more accurate assessment of the variation of a data set, but it doesn't come without its challenges. It does have a formula, as you might be peeking ahead at here, the square root formula there. So just to set the stage here, so let's just say that we have n different or n values of data. So some of them could be the same, some of them might not, but we have a sample with n values. And let's just say that we also already know the mean. Now remember that the mean has the symbol x bar, which I'm highlighting there. Okay, so the standard deviation is then computed by following this formula here, and you notice it's pretty complicated. So we have these things that are squared, and then we're adding them together, and then we're dividing by something. So remember that n is the sample size. Okay, so how does all of this come about? Well, let's just look a little bit more in detail at some of these things. So these things that we call x1 minus x bar, x2 minus x bar, etc., those are what we call deviations, okay? And a deviation is just how far away something is from the mean. So if I have 10 different data values, I'm going to have 10 different deviations because I'm going to be subtracting all data values and the mean. Okay, so that means that these are all deviations. So another way of looking at this is the sum of the deviations. Now, it's not just the sum of the deviations, though, because what we're doing is we're squaring them and dividing by n minus 1 and then taking the square root. So think about your order of operations. That square root is a grouping symbol, which means everything underneath the square root has to be completed before we can talk about taking the square root. There's no shortcut here. So here's the way we're going to organize the data to make this seem a little bit less complicated, and I hope that it will be. So the first thing we're going to do is make a table with 3 columns, where the first column has our data values. So you might be given a bunch of data that looks like this. Okay, so this is my x1, this is my x2, this is my x3, and so on. We're going to put them in a column so that we can more clearly organize this data. Then in the second column, what we're going to do is we're going to find the corresponding deviation, which just means subtract the mean from it. So in there, we're going to have to subtract, or we're going to have to find the mean. Okay, in the last column, all we're going to do is take whatever's in the second column and square it. Okay, then we're going to add up that third column, and that third column is the numerator of the standard deviation expression. Okay, so that right there is the sum of the third column. In fact, I'll write that here. Sum of last column. Okay, and actually my pen is writing a little bit thick here, so I'm going to change that if I can. Oh, it is right there. Okay, never mind. I don't know what's going on then. Okay, so then what we're going to do is divide by that n minus 1, and then we're going to take the square root. Okay, so best illustrated by looking at an example. So let's take a look at 1, and then we'll see where we are. So here's a set of data. There's 10 values here. You can count them. Whoops. 10 values. So the first thing we need to do is find the mean, which we know is just taking the sum of all of those values and dividing by the number of values. Now, I encourage you to do this on your own, but the sum is going to be 50, which means the mean is 5. So who knew that this would work out well, right? So the deviations are, so it's going to be every x value minus x bar. Okay, so we're just basically going to subtract 5 from each value. So 1 minus 5 is negative 4. I'm just going to write that up here. 1 minus 5. So 2 minus 5 is negative 3. 3 minus 5 is negative 2. 4 minus 5 is negative 1. There's 2 of them. 5 minus 5 is 0. There's 2 of them. 6 minus 5 is 1. 9 minus 5 is 4. And 11 minus 5 is 6. So what we do to go from the second column to the third column is we square everything. Now remember that squaring a number will always produce a non-negative number. And I say non-negative because if you square 0, you get 0. So if I square negative 4, just to illustrate here, that's negative 4 times negative 4, which we know is positive 16. So every number in this third column should be a positive number or potentially 0, never negatives. So if I square everything in the second column, here's what we get. Okay, and now what the formula says is these are the squared deviations. So now that's the column that I have to take the sum of. And that looks like 31, 32, 48, 84. So that means that the standard deviation is the square root of, so it's the sum of the third column divided by, now, if n is 10, that means n minus 1 is 10 minus 1, which is 9. So at this point, what we're going to do is go right to our calculator, and we don't have to do anything fancy with this. I would always suggest putting in expressions as completely as you can so that there's no rounding problems. Notice once I hit the square root, I just put inside 84 divided by 9. It knows what to do. Press enter, and we get 3.055. So that is our sample standard deviation. Okay, so that is computing one sample standard deviation. Let's look at a second one just so we can get into the rhythm of it here. I think we're really starting to understand it here, hopefully. So here's another data set. Now this one is a little bit different in that we have basically two values. We have 0s and 10s, so it's kind of polarized, if you will. Now there's still 10 values, and I'm just going to tell you right now that the mean is 5. You can probably see that. If I were to add up all the values, I would get 50, and then 50 divided by 10 is 5. So that means the deviations, well, that means, again, remember, we're subtracting the mean from every value. So that means these deviations are all the same, negative 5. And these are all 5. So the deviation squared is 25 for all of them. So this is an interesting result, isn't it? So if I take the sum of that third column, that's what we're doing here, right? The sum of that third column, well, that's 25 10 times, so that's 250. So that means that the standard deviation is the square root of 250 over 9. And again, we'll go to our calculator to figure this out. So square root 250 over 9. And that gives us 5.27. So it's larger. Now you're probably wondering, why did that happen? Well, here's the idea. So the standard deviation is going to get larger if we're adding bigger numbers in the numerator. So what causes us to add bigger numbers in the numerator? Well, bigger deviations. So what this means is larger deviations mean that the standard deviation will increase. Now that, of course, means that we're keeping the same mean and we're keeping the same sample size, okay? Because those are, if we change too much, then we kind of lose the comparison idea here. But if you have, if you have data that looks like, well, looks like this, for example, here. So these we're either 0 or 10. None of the values are close to the mean, which means we're not going to have any small deviations. They're all going to be large, okay? So that's going to produce a larger standard deviation. Here, we had some values that were close to the mean and some that weren't, which means we're adding up some larger numbers, but instead of some of the large numbers we got down here, we're adding up some smaller numbers. So that means that's going to make our standard deviation smaller. So that's comparing those two. When we come back, we're going to look at two more where some other special things happen. So stay tuned, and I thank you for watching.